Okay, so we just got done adding the query tool. So we just got done adding filter, select, top, skip, and the other one, order by. What we're going to do now is start to get into the really powerful stuff, which allows us to do all that while expanding relationships and drilling through and doing joins. So again, one of the most powerful features of this whole OData environment. So in our customer data, we have 5 files, and in fact, they're all related, and we can drill all the way through all 5. And in fact, we'll demonstrate that in a little while. And I'm going to use some fairly simple, I'll probably use some expand and some select, but you can filter and order by and all of that good stuff, all in combination in some very complex expressions. So yet again, what we're going to do in this is we're going to edit our generation file, and we're going to say we'd like to enable support for relations, please. And this is going to make several things happen, and we'll look through all the code that changes. So it's going to add additional properties into the model classes. So every time you've got an outbound relationship to another structure, we represent that as what's called a navigation property in the model. So if customers have orders, then the customer model, as well as customer number and name and all of that sort of stuff, will have a property that is the orders that customer has. That data may or may not be populated, depending on whether you ask OData to expand that relationship when you make a query. There will also be additional code in the metadata classes that describes the relationships to the entity data model. There'll be additional code in the startup class to enable expansion, and there'll be additional code in the API Swagger file. I don't think we've yet extended the Postman tests to know about expanding relationships, but that's purely because we just haven't got around to it yet. At some point that will happen. Let's actually make the change first of all. So let's go and edit our regen.bat file, and we'll turn on enable relations. So that should be all we have to do to support generating this code. So let's go and tools generate code. I'm using my shortcut key. So we've generated some additional code into our environment. Again, no additional files have been added, but we've altered some things within our environment. So the first thing that's changed is the model classes. We should now have these navigation properties. Let's go and take a look at one of those actually in situ. So if we drill into our models folder, you can see everything's changed. We've got the red check marks. And if we look at customer, here's our constructors. Here's our attributes, which are the properties of the entity. And somewhere down here, we should have, are they right at the bottom? Here we go, right at the bottom, we've got this new region called relationships to other entities. And as you can see, we've got public read-write property. We prefix the name of all of these things with the word rel underscore, okay? And then use the name of the key as defined in the repository. So this is another one of those instances where if your keys have bad names, and really nothing really uses the name of the key in the repository to date, so it's highly likely that people put literally key 0, key 1, key 2, key 3. So you might have to go and rename. In fact, I don't think you can rename, but you can copy a key definition to a new name and then delete the original one in the repository. So it's one of those areas that you might have to do some incremental improvements to your repository in order to get meaningful names in this environment. And unfortunately, there's really nowhere in repository, key definitions don't have long description fields. And that's the way we typically use to extend and provide additional metadata. So there's really no way for us to provide an alternate mechanism easily to rename keys. But we prefix them with rel underscore simply to avoid collisions with other fields that might already be in the structure. Because there might be a field called favorite item. In fact, there is. If the key happens to be called the same as a field, then the property name would collide. So that's why we use the rel underscore prefix. As you can see from this example, some relations go from each record in this file to a collection of other things, multiple orders, and some things are a one-to-one type relationship where each customer has a single favorite item. And you see that represented in the properties. We also have some changes in the metadata file. Again, rather than actually doing that, let's just take a look at those changes in one of the items. So let's look at customer metadata. And as you would expect, we've added 2 additional add field info calls to describe 2 additional new properties that are now available. And we've described one of them as collection and one of them as data object. So this is a one-to-many type relationship, and this is a one-to-one type relationship. Again, entity framework or the EF provider is drilling into this information to discover what's out there and what's available. And then that's just some changes in documentation. And then in the make new, which is used, metadata make new is used to create an instance of a data object of this type. And we've got some code that initially populates the two properties with the appropriate values. Okay, and that's really the changes in the metadata. We've also got some changes in DB context. This is really to help us debugging things, but we kind of have, right now we have 5 different types of join or relationship, and we've arbitrarily named them type A, type B, type C, D, and E, just so that we generate this information into the file so we can help, it helps us understand what kind of relationship it is. There are 5 different behaviors. Basically are based on, is this thing what we would traditionally call, we think of a one-to-one or a one-to-many typically for every relationship. We actually take it to another level because in relations, generally speaking, you've got a relationship out, but in most cases there's also a relationship back in the opposite direction. And that's why we've got more than 2. So the 5 types we've encountered and think exist so far are a one-to-one relationship. When I say that, I mean from the current record, so it's always a 1 to something outbound, right? So it's from the current record, targeting 1 on the other side, but with a 1 to many coming back in this direction. Okay, so we are one of many matching, we're targeting 1, and there's a 1 to many in the opposite direction. That's what we call type A. And there's just variations on the theme. So the second type is a 1-to-1, where there's a 1-to-1 in the reverse direction. We've got a 1-to-1 with no relationship defined in the reverse direction. A 1 to many with a many to 1 in the reverse direction, and so on. So those are the 5 different things, and each of them are treated slightly differently. Some of this syntax blows my mind, to be honest. It's interesting, to say the least. Let's look at an example. So here's the DB context with its changes, and as you can see, well, we don't need to look at the changes. Let's look at it this way. It'll be easier to see. We've just got a whole section of entity relationships. So here we're in DB context, and we're saying the entity customer has a relationship to many orders, essentially, with one of these. Yeah, okay, I'm not even going to try and explain each one of these, but hopefully you get the point. This is how we're describing these various types of relationships to entity frameworks so that it correctly interprets and knows that you can go this way and you'll find many, and on this occasion you can't come back, but other occasions you can, and so on. Take a look through it and you'll figure it out. It's not important that you understand this stuff, by the way. This is just the plumbing that happens under the hood to describe this stuff to entity framework. Okay. One of the challenges right now is I'm not sure we do a great job of surfacing the names of the relationships. So you kind of, in some cases, I'm not sure if they appear in the documentation in the Swagger docs, for example. If not, we can make them, and we should. But now there's a couple of occasions where you just have to kind of know what the name of the relationship is. So that's one area that I'm aware we need to improve on and surface that information better. Startup class changes is a very simple change. We just build a .expand, just says turn on the ability to expand relationships. So we'll not bother drilling into that one. Pretty straightforward. And again, in the Swagger documentation, you're going to see an extra field because expand is enabled. Then you will be able to drill into those relationships. And once you've got it defined, then you're able to follow those relationships with the expand keyword. So let's build it, and let's just do a couple of things manually. In fact, we'll just use these. Let's just grab these URLs. So here we're saying we're going to drill into OData customers, and then the query string, question mark, is the beginning of the query string, $expand equals rel orders. So we're saying I want to retrieve all customers, and for the customers who have orders, I would like to see the collection of orders as well. Is our service running? No, I guess I built it and not run it. So let's run the service. And let's go to our browser, and let's paste that URL in. First one always takes a few seconds. There we go. So here's customers drilling into orders. So here's customer number 1, rel orders, empty array. So customer 1 doesn't have any orders on file. Okay, if we drill down, customer 2 does not either, nor does 3, nor does 4, or 5, or 6. Okay, customer number 7 has a single order in the system, and that order number is 7. But you see how the expansion of the relationship worked there. Let's look at another example. let's try another thing here. So that was for all customers. Clearly, we can also drill into an individual customer and do the same thing. So here we're drilling into customer number 8 and retrieving their 3 orders that are on file. So we're just following that relationship through. Now we can be selective about what fields we want at both of these levels. So for example, we could say customer number 8 $select equals, let's say, customer number, comma name, and expand orders. Oh, no, we can't. Oh, and, sorry. Each clause of a URL it's question mark starts the query, and then it's item, ampersand, item, ampersand. So there we go. We've now been selective about the fields at the customer level, but we're returning all order fields. And if we wanted to, we can do other things here. So if you want to do things within an expansion, so we've said expand rel orders, and if I want to do additional things there, we use parentheses, and then we use our expressions again. So here we could say $select equals, let's just pick one field, let's say date ordered. So now we're just getting that one entity from the order items. So you can construct and combine these things however you wish. What was the third example we've got here? Oh, this is an example of going 2 levels. Okay, so let's just take this one. And we'll just paste it into our browser. So there's an example of drilling down 2 levels. We're drilling off customers 8, beginning of query, expand equals rel orders, beginning of parentheses to begin a query on that one, and then expanding into rel order items. And if we want to expand into that one, then we have more parentheses and so on. So you can build up extremely complex expressions using this stuff. Here's an example, look, that I'm just going to copy and paste that one. So here, we're going all 5 levels down. This is the example I showed the other day on the slide. So we're starting off at a specific customer with selected information, drilling into their orders with selected information, items, item ordered, and right down to the vendor of each item. And again, if we try that in our browser, then sure enough, we're drilling through 5 ISAM files, doing 4 joins with sparse along the way. Haven't got any order bys and filters in here, but we could equally if we wanted to. Okay, awesome stuff. Okay, so let's close down our server and let's save this stuff away. Okay, so that's it for our read-only service. Okay, we're done adding informational endpoints, get endpoints to our service at this point. We're exposing all of our entities in their collection form or in individual forms. We're exposing individual property endpoints. We're exposing collection or single entity endpoints based on all alternate keys. I think all of our alternate keys expose collections of things, but there are clearly an alternate key could potentially expose a single item, and we just don't have any examples of that in our data set right now. We need to invent one. So we've got the count functionality, individual properties I mentioned, we've got the relations, we've got the extended query syntax supported. So that's pretty much the extent of what our get-based services do these days. Now we need to move on to looking at creating things, updating things, deleting things, patching things. Just as a reminder of what we said the other day, in this world we use 5 of the HTTP methods. Get, we've already looked at pretty extensively now. We're also going to use post, put, patch, and delete. Again, as a reminder, the discrimination between post and put is slightly different from what we've described, and slightly different from what most REST API discussions describe. Most of them say post is a create, put is an update. Okay? This is slightly different in this world where post, we are saying, is always a create of a full entity where the primary key is going to be automatically generated. Now I will show you that mechanism that we've built in to allow you to extend with custom code. In fact, we're going to do it. We're going to provide, the custom code's already there in the project, but we're going to plug it in and enable it and show you how it works. So a post is always going to be a full create of an unknown entity ID, and we're going to generate the entity ID on the server. The put is typically considered to be a replace. So it's an existing entity and you are replacing the full thing. So every property is going to get a new value. Or if the entity does not exist, then the entity will be created with the provided primary key. A patch is a partial update field by field. We've seen examples again before, but we'll look through that again. And a delete is fairly obvious. We're going to go and delete an entity if it exists. We do have support in, now it suddenly occurred to me yesterday that I guess when we were designing this environment to start with, I just naturally assumed that you would always want the get things surfaced, at least the collection and the individual. So the way the batch file works right now, you don't have a choice. But I guess there are scenarios where you might want a write-only service. So I'll probably be adding an additional layer of settings in the batch file to suppress all the get stuff, so that you could just have a create-only or an update-only or something like that service. But right now you don't. We have separated them out so you can individually enable put, post, patch, and delete with 4 separate settings. What we're going to do here is just generate additional operations into the controllers, and we're going to generate additional YAML and additional Swagger file documentation. And remember, the post, put, patch, and delete are already in the Postman file. I forgot to parameterize those, so I will be fixing that in the upcoming days. So let's go ahead and do it. Let's go and edit our Regen file, and we're going to enable all 4 of them. So we'll have put, post, patch, and delete. Oops. And enable all 4 at the same time. We'll save it. We'll regenerate the code, which is now done. And what did it do? So if we look at what changed, primarily what changed was our controllers now have additional operations. So we've now got one additional piece of information that we are injecting through dependency injection. There is a thing called an iService provider. So this is surfacing the primary key generation stuff. So we're injecting, and you'll see what this is and how it works in a moment. So we're using dependency injection to get one of these iService providers into our controller classes and making them available, therefore, to the operations. These are the same operations we had before. Here's our get all, get one, all the alternate keys, all of the individual property endpoints, and then here are the new ones. So now we've got a route of customers. Well, we've already got a route of customers, right? We can go to customers to get all customers, but now notice that the method is called post customer. So if you use a post operation to the customer's URL, this is where you're going to wind up, okay? And what we're doing, first of all, is Web API has this thing called model state. The typical use of model state is like this. Model state has a property called isValid. So what this is doing is, if we look in our model classes, let's look at customer, for example. I kind of skipped over this earlier intentionally to discuss it at this point. So if we look at the attributes, the properties of the customer model, you'll notice that some of the attributes, when the code generation took place, have these attributes applied. And these are what are called system.componentModel.data annotations attributes. Okay? That namespace allows you to attribute the properties. For example, here, we've exposed a name called string, or a name of type string, right? String is a variable, it's an object, right? It's a variable length. But under the hood, we've got an alpha variable, okay? And that alpha variable has a fixed length. So one of the data annotations is string length 30, and an error message is customer name may not exceed 30 characters, okay? So we've placed a constraint on that property that the Web API environment knows about and will validate for us that the string may not be longer than 30 characters. And there are about 15 or 20 of these attributes that you can apply to do numeric range validation, required field validation. There's one that validates that the value looks like an email address. There's one that validates that it's a zip code. There's one that lets you specify a regular expression to say, does this value match this expression? So there's lots of different attributes that you can apply. When we do code generation, we just apply a few basic ones. So primarily string length. Repository has a is this field required flag checkbox that you can set. And if that is set, then we apply a required attribute. And I think we do some numeric range stuff as well, because repository has numeric range capabilities and maximum values and things like that. So you'll see these attributes appearing based on how your repository structure is set up. Okay? And back in our controller, we've got here, if not model state.isValid. So if model state is present, the web API infrastructure below us is going to analyze any data that comes in and compare it to the rules that are defined through those data annotation attributes. And if anything is wrong, model state.isValid will be false. So at that point, now I'm dealing with this in each and every controller operation, and if we find model state.isValid, we return bad request. That's an HTTP 401 bad request, I forget what it is, but we're returning to the client bad request model state. And model state contains a collection of all of the exceptions. So that error message that was in the code, string, customer name may not be greater than 30 characters, will be part of that model state, so it goes back to the client so they know what the problem was. Okay? Now, I may be changing the way this works. This is happening in every controller, but it is actually possible to cause this validation to happen in a filter before the controller gets called. So it just kicks out the request without it even getting to our code here. So if this model state.isValid goes away at some point in the future, it's because it's being handled in the pipeline earlier on, and your method won't even get called if there's bad data. In this case, what we're doing is we're doing a post. So we're saying a post, we do not allow a customer ID. Okay, we are going to pick the customer ID. So I'm saying model state.remove customer number. So I'm saying if the client passed me a customer number, throw it away, I don't care. I'm going to pick one. Okay? And then here is where we're using our primary key factory. So we're creating an instance of this iPrimary key factory, casting service provider, get service type of iPrimary key factory. Okay, and then we're using keyFactory.assign primary key to the customer record. Okay, so what does that code do? If we look in, where is it? It's here. It was provided in the original code. This code is included in the workshop project templates, but is not included in the standard Harmony Core project templates because it's a specific implementation for the workshop. Okay, but this is what you would do if you want to support post. You would have to create a class that extends record primary key factory and basically do as we are doing here. And basically what this code does is, as you can see, it's opening the sysparams file and it's figuring out what kind of, based on data instance RPS structure, so based on the metadata for the current thing. If it's customers, we're going and reading whatever record. So next customer number is record 1 in the relative file, next item number is record 4, and so on. So we're literally going off and reading our next customer number from wherever we get it in our system. So for any files that you support, the generation of the next available key number, you would have to implement a mechanism similar to this. Okay? So you can look through that code and see exactly how it works. So that's what our post code is doing. Let's go back to, we're in there. Let's just go control minus, okay, minus, where are we? Here we go. Okay, so we remove the customer number, we make sure the data is valid, we use our key factory to go and assign the next available primary key, and here's where we're using the EF provider again, DB context, customers add a customer. Okay, so we add the new customer record, and as Jeff's mentioned several times during the week, the EF provider is using its transactional support, so nothing actually happens until we call save changes. Okay, so if we had a complex method where we're creating a customer and an order and a bunch of items and doing a whole bunch of stuff at the same time, we would use the EF provider to do all of those individual things, and when we're done, we call save changes, and all of that becomes permanent in the underlying files. And then the convention on a post, because an entity is being created at an unknown key, is we are going to return, the HTTP actually has a status code, which is it 201 created? I think it's 201, and we return the customer record. So we're returning the full entity that was just created, now including the automatically generated primary key. Also, when you return a created status, Web API will add a HTTP header called location, and it will contain the URL that can be used to access the newly created entity. I'll show you all these things happening in a moment. Here's our put. I'm not going to go through all of them in so much detail, but they're all fairly similar at this point. So put customer is expecting you put to a specific customer URL. So we have the customer number coming in through the OData URI, but notice now we have a customer data object, an instance of the customer model coming in, and it's attributed as from body. Okay, so this is an object or a JSON representation of an object that has to come in the body of the HTTP put request. Okay, and I'll show you all this happening in Postman in a couple of minutes' time. Again, we make sure the model state is valid. Here what I'm doing is I'm saying, well, they have to provide me a customer ID in the URL, but they could have also included a customer ID in the body, in the data object. So I'm going to override that and say the data object customer number is always the one passed in the URL. So if they pass me different values in the two places, URL wins because we're doing a put to a specific named entity according to the URL. And then we simply put the thing in the database. So here we're doing we need to know if it's already there because we're going to either update or create. So what we're doing is using the EF provider to go and find by primary key customer number. If it is not found, we do a EF provider.add and save changes, and we return a created status and the data. If it is found, then we're copying the new data over the existing data and doing a save changes and returning a no content. Okay? So typically, if you ask a web service to do something like update an existing entity, you typically don't get data back. You know, you've asked it to update something, it does it. It doesn't need to send it back to you because you already know everything about it. So the common way of signaling success is to return a no content status, which simply says it was successful, but I am not returning any data. Okay, that's what no content means. And if there's any problems with any of this along the way, if we get any exceptions, we're simply going to return bad request. Okay. Patch is very similar, other than it accepts a customer number through the URI, and it accepts a JSON patch document, which is a certain structure, a certain format of a piece of JSON through the body. And again, I'll show you this happening in Postman in a moment's time. Again, we check the model state. Again, because we're updating something, we use the EF provider to go off and read the existing one. If it isn't there, we return a not found. If it is there, then there is a method on the data object called apply to. We use the patch document and apply the patches to the record that we just read from the file. Okay, and then again, update, save changes. Okay, again, anything goes wrong, bad request. Actually, I don't think we actually need this try-catch error handling in here, because if something goes wrong, Web API will just turn an exception into a bad request anyway. Oh, no it won't. No it won't, it'll turn it into a system error. Okay, never mind, ignore me. And finally, delete, same kind of concept. We're not taking any data in the body now, we're simply taking in the customer number from the URL through the from data URI parameter, finding it, use the EF provider to find the existing record. If it was not found, return not found. If it was found, remove it, save changes, and again, return no content, which signifies success but no data coming back, but your delete was successful. So that's the changes. There are similar changes in all the other controllers. I think that's probably all we need to discuss. This is just a slide version of all the stuff we just went through: patching a record, deleting a record, generating primary keys. Yeah, we've got the code that does the primary key generation in our project, but it is not set to compile. So what we need to do is go to primary key generator, right click and go to properties, and you'll see its build action is currently set to none. So we need to compile that code now, so I'm going to change it to build action compile. And I'm going to do a Control-Shift-S to save all changes just to make sure that project file gets updated. And I believe that's all we have to change. Yeah, we've looked at primary key generator already, showing you how it's based on the metadata and based on which structure it is, going to the relative file and reading the next available number and so on. So let's try it out. Let's do some CRUD operations in Postman. So let's do a build and make sure it does. Okay, so we're built. Let's run it up. We'll do a run without debug, Control F5. We've got our service running. Now this stuff we can't test in the browser. You can only do gets in the browser. So we're going to go off to Postman. I'm going to close down all the stuff we've got open already, and I'm going to re-import the Postman file so that we get all the latest. Oh, actually we've got the ones we need anyway, but let's just make sure we're up to date with the latest version of everything. Okay, so now we've got 173 different requests in our Postman environment. Let's play with customer, I guess. So let's go off, and if we look way down here, we've got post create customer auto assign key. Okay, so if we select this one, we've still got our base URI to our customer's endpoint. Notice now that the method we're using is post. We will be sending data to the service. So if we look in the body of the request, you'll find that I've pre-populated some customer data. Notice I have got a customer number there. I need to fix this. I'm going to take it out. It doesn't need to be there. Okay, so I'm going to take the customer number out. It is JSON data, so whenever you're sending data to a web server or web service, you are expected to identify the type of data that you are sending. The way you do that is by adding a content-type header to the request, and its type is application/JSON. So that is you saying to the web service, I am sending you JSON data in the body of the request. Most tools, including Postman, will also add a second header that is content-length, and it will calculate the number of bytes in the body and tell the server how long the data is as well. But we don't have to do that manually. Postman will do that for us. So we're sending a content type application JSON. We're sending body with XML data. Notice it's Abe's Nursery, 1032 Main Street, Springfield. We're doing a post. Let's see what happens. So first one always takes a few seconds. Oh my goodness, what have I done wrong? Oh, yeah. Where did I miss that instruction? Ah, yes, I missed it here, look. Startup custom needs to be, okay, so we've got a custom startup file. I'll show you how this mechanism works now as well. Startup custom is also in the project and is not compiling right now. There we go. Okay, so we'll save the changes and we will do a build. So when we were setting the build action on those two files that had been provided but set to no compile, those changes were not being saved into the project file. We ran into this last week and we thought doing a Control-Shift-S was enough to force it out there, but in this case it doesn't seem to have done. So that's what had happened. The setting the build action had not been done. So hopefully now if we build, we should have both of those things in there. All we did was I right-clicked on services and said unload project, and then edited the project file and looked at the files, and these non-include equals is the build action is set to nothing, and I changed the two that I wanted in to say compile include equals, and then reloaded the project file. That's a little issue that we've got that we will get resolved as soon as we can. So we'll reload that again. I believe I built it already. Let's do a Control F5 to run it, and hopefully this time. Okay, there we go. So pretty view. So we called it, again, first one's always a little bit slow, so it took a couple of seconds. I'll do it again in a moment, but you can see it's returned to us a status 201 created. Postman tells us there, no, it's kind of small. Actually, we can do that. You can see 201 created. The request has been fulfilled and resulted in a new resource being created. Other things to look at are, you can see in the response body, we've got the data coming back. We did not send a customer number, but a customer number has been assigned, and it's customer number 39. So there's our primary key generation logic taking place. Also, things to note is if you look in the headers, the response headers, when you do a create, it is correct behavior that you return a location header that gives you the URL that you can use to access the resource that was just created. So that's a nice little programming thing as well for client developers. So that worked. In theory, if we hit send again, it should be a little bit faster this time, 32 milliseconds to create this one. So that couple of seconds spin up time is just there on the first request always. on all services. And you can see that this time we created, if we go to the body, order number, customer number 40. Now with the same data, because we're hard coding all of the data and all that kind of stuff. But there's our post working. If we want to create or update an existing customer, I think this one is probably pre-set up for the body. Oh no, okay, so this one is set up. Here we are providing a customer number 355232. Let me just copy that value so that we can refer back to it in a moment. So now we're doing a put, and we're doing a put to the specific URL of the entity that we are attempting to. In this case, it's going to do a create because that entity does not exist right now. Okay, so remember, put is either a create or update. So if we do a put at this point, we should expect to see 201 created. Okay, and if we look at the response data, there's the data coming back, and this time the customer ID is as we requested. Okay, if we now do an update, let's change something. Let's change it from Abe's nursery to Steve's nursery, and we'll do a send, and now we get a 204 no content. Okay, so a different response. 201 created says I created an entity and here it is. If you do an update, it just says, yep, that worked, and no body comes back. Okay, and this is just normal RESTful API behavior. If we want to verify that it works, we should be able to go off and do a get. So let's do a read customer and inject the customer number that we know we just created and do a send, and sure enough, there's the data we just updated with Steve's nursery. Okay, so that's create via generated key, create via specified key, update, all three of which are replacing all properties of the entity, or at least all properties. Well, they're all getting rewritten anyway. The other operation, of course, is patch. So let's take that same customer number and we'll inject a 35532. Let's give it, where's the request body? So here's an example of our patch document. Okay, so if I wanted to change, what have we got? City, Springfield, Missouri. So let's change, where are we? Let's change city to New Orleans. And while we're at it, let's do a second patch in the same operation. We'll have a comma in there and say we'll set state to Louisiana. Oops. Okay, there's our patch instruction. Remember, we're going to update this customer that we just created, 355232. So here's our patch. We'll do a send, and it said, yep, 101 milliseconds. We've done those two updates, and if we go retrieve that customer again, we should find that the city and state are now New Orleans, Louisiana. And in this case, remember, the difference between a patch and a put is, in this case, the only two properties that were updated was those. Okay? And the final one, of course, is a delete. So let's do a delete. We're deleting to a specific customer URI, 355232. Delete 355232. We're not specifying any headers. Actually, we are. Yeah, that's irrelevant. We don't need to for a delete. That can be removed. We're not specifying any body or anything like that. We're just doing a delete to that URI, and hopefully we get back a 204 no content. Okay, it did it. Whatever it was we asked it to, it did it. Nothing came back. Customer's been deleted. In theory, if we now go back to retrieve that customer again and do a send, 24 milliseconds, and we get back a 404 not found. Okay? So this is how RESTful APIs work explicitly with HTTPS as a protocol, or HTTP as a protocol, dealing with the get, post, put, delete, patch methods, dealing with the URI, and the return statuses being actual HTTP return statuses. It's a very, very, very simple API and a very, very usable API from anywhere. It's awesome. Okay, so that's primary key generation. We looked at the source code. We've played with create, read, update, and delete. Let's save those changes away. We're getting towards the home straight at this point. So let's do CRUD and commit that. Okay, what's next? What we're going to do now is look at how we can support custom functionality. Okay, just one simple example. It's all well and good having collection of customers and a customer and drilling into it and creating and updating, deleting, but what if you want to do something custom? So what we're going to do is add an arbitrary piece of code and expose it as an OData operation. We're going to just write an arbitrary class and we're going to attribute it as controller. Okay? This is the mechanism that Jeff picked the lovely name Sprach for. I think Sprach stands for stored procedure. Okay? Because it's kind of the stored procedure concept in a database. So what we're going to be doing is writing a class, or we're not going to write it, it's already there, we're just going to bring it in. It's provided in the environment. And we're going to have an arbitrary class that we attribute as controller. And Jeff's got some wonderful plumbing that says, oh, there's a class attributed as controller. I'm going to look at all of its public methods and I'm going to stage them as OData endpoints. So the routing mechanism here is going to be OData. Actually, this is not strictly true. I'll show you what happens in a moment, but conceptually, we're going to route to OData into our class and into our method. It's not actually the class name. The name is actually applied by an attribute somewhere. I forget exactly where, but we'll come across it in a moment. So strictly speaking, it's not the actual class name. You can specify exactly what you want the name to be. By default, we use post to activate these kind of operations. And if you want to use a get, then there is an attribute that you can apply that I forget the name of now, to be honest. Don't remember. Anyway, there is a mechanism to say, no, this is just a get, where we're just retrieving information. And dependency injection through that same mechanism where you just declare a constructor and say, I would like a copy of the DB context, for example, is fully supported in this environment as well. So what we're going to do is let's take a look at the code. You've already got the code. It is in custom functionality folder, and it's called orders methods. And it simply has a class in there. You'll notice here's our controller attribute. So this is what's going to make Harmony Core stand up and take notice and go, ooh, there's some stuff I can expose here. And it's going to look through and it's going to find this method called orders methods. Sorry, the class orders methods. There's the constructor, and again, we're using dependency injection to get the DB context and the service provider that provides the primary key generator, just like we do in the other environments. Our custom functionality is going to be create new order. So we can create an order through posting to the orders endpoint and through posting to the order items endpoint, but what this operation does is both at the same time. So it accepts an order and a collection of items, and it creates all X number of records in both files at the same time. So our parameters, we're accepting a single order data object, and we're accepting a order items, which is a collection of order item data objects. And we've just got manual logic in here. We're doing some validation to make sure we've got at least one item on the order. So you might need to add some more complex validation in here to make sure things are good. Model state validation. This example is just an arbitrary class with an arbitrary method. But if we actually implement an actual endpoint in a controller, then we still get model state validation. So all we've got going on here is we're extracting the key factory from the service provider. We're using it to assign a new primary key to the order. We are then iterating through the order items that we were passed, assigning the order number and incrementing the item number as we go, making sure we've got items 1, 2, 3. And then we simply use the EF provider to add the order. Look how cool this is, order items.addRange collection. So that adds one order item or 1,000 order items or whatever's in that collection, and then we save changes. And as Jeff indicated the other day, it all happens or it doesn't, subject to the power not going out. Okay, very cool. And I'm returning the order number of the new order that was created in this instance, so that'll be the return data that we see coming back. Okay, so let's check for other instructions, because I know we've got some stuff we need to turn on. So this is the method, we've looked at that already. So this is essentially what we're going to wind up posting to it. So our JSON message is going to be an order object. Sorry, here's the object. Within it, there's a property called order, which is an order, and then there's order items, which is an array of individual order items. So we're combining a hierarchy of entities here. What we're going to do is we are going to edit our Regen bat file and turn on support for doing this kind of stuff. Okay, so we'll enable Sprach, and we will generate our code. And we will take a look at what changed. And basically, in the startup code, you can see we have simply added one line of code, okay, to say we're inserting a new route generation thing called Harmony Sprach routing convention. That plugs into the pipeline an extra routing rule that routes to these methods that are in classes that are attributed as controller. Okay? Now then, what we have to do is we have to change the build action on orders methods. I think, did we do that already? Orders methods, properties, no. So I'm going to, oh, well, again, this may or may not work, so let's try it this way. And let's do a save while it's on that screen and see if that makes a difference. Control-Shift-State or edit startup custom and uncomment. So we've got one additional line in our custom startup code, and I promised you I would show you how that works, and I haven't yet, but I will. So here's our custom startup code, and we've got this line of code that was already in there. So what this is doing, this is basically turning on or adding the dispatch mechanism. So we added a routing mechanism for it, and this is actually plugging in a service that does the dispatching, okay, in the startup custom code. Okay, let me just, is that all we have to do? Yes, let me just build it, and I'll show you how this custom code works, because it is quite cool. So the way, this is done through partial methods. So our two primary extensibility points at this time are partial class and partial method. So partial class is all of our models and controllers and all of that kind of thing are partial classes, so you can add a second half and add your own methods and add your own operations and things like that. Okay, now it built. All right, so back to the custom stuff. The way that custom, so we got the extensibility points where if you look at any of our models, public partial class, so you can add a second half to do your calculated properties if you wish. If you look at our controllers, public partial class, so you can add a second version to have your own endpoints and custom code. And the third extensibility point is if you look, for example, in our startup code that we generate, in here you will find, so here we've got, this is a mechanism called partial method. So what partial method does is it gives you, it provides a mechanism for you to extend the code in a certain way by providing an implementation of a method that the environment will call if it's present. Okay, so by declaring partial method configure services custom and the parameters you want, end method, notice there's no proc there, so it's declaring the existence of, or the possibility of one of these methods being present. And there's also partial method configure custom. So we got configure services custom and configure custom. Those are those two areas of the startup code, okay? But no implementation. These are just declaring the presence of a partial method. So what happens is, if we go into our startup custom, you can optionally provide this file if you wish. So again, it's public partial class startup. You're adding additional startup code to the same startup class. That's what partial class does. And in here, we've got the implementations of the partial methods. Okay? So you can write custom code. And what you will find is if you look back in the original startup code, if we look in the first of the two methods, which is our configure services method, after we've done all of our stuff, we call configure services custom and pass along our parameters. And that's a call to the partial method. So if you've provided a partial method at this point in a partial class, this code will call it. If you haven't provided it, this code does nothing, because there's no implementation of the partial method. So it's a great way of us putting a hook point that you can add a method if you want to do some custom code, and it will just get called through this mechanism. And the same is true at the end of the configure method here. Here's all of our standard configuration stuff, and then right at the end, after we're done, we call configure custom and pass along our parameters so that you can run additional code if you wish. Very cool. Okay, so what did we just do? Oh, we added our custom function. Okay, so in theory, we built it, so we should be able to run up the service. And in theory, again, we're posting something here, so we need to use Postman. I believe I've got a test in here somewhere. Oh, it's in here, Harmony Core custom functionality. There is an import file, I think, in the project file that has these 3 tests in. So here's a test for create new order method. Okay, so you can see we're posting to, oh, I didn't show you orders methods. I didn't show you where the name actually came from, and I said I would. There. So in the custom, oh, we're in the EDM builder. Okay, have I missed a section? Yeah, I've missed a section. I need to turn that one on as well. Sorry, I guess I had something missing from my instructions. We've also got a custom part of the enterprise data model builder, which I need to set to compile as well. Let's do that, and I'll show you what it does. Sorry, I apologize. I'm kind of losing my way a little bit here, but we'll get back on track. Okay, so let's enable that file and re-enable that project and build it. So there's also a custom part of the EDM builder class, which extends the EDM builder with builder, add methods, order methods. Oop, it's running. Build. So we're adding a definition of the custom stuff. Remember, the enterprise data model knows about all the entities and the relationships between them and all that kind of stuff. So we're telling it that there is something out there that is implemented by the class orders methods and is available at the route orders methods. So when I said that route to it is not the actual class name, it's whatever you specify here. Now in this case, they're both the same, but if you wanted to have the route be something different from the class name, then you'd specify the class that contains your custom methods here, and this is the part of the route that routes to it. Okay, so did that build okay? It did. Let's run up the service again, and maybe this time it'll work for us. So we're posting to orders methods, which is that thing that we just looked at. Create new order is the name of the method in the associated class. We are sending a header, which is content type application JSON. We are sending a body, which has got our order header data and 2 order items. Okay. Notice we're not specifying an order number because we're using the primary key generation mechanism in our custom code to associate the order number. And let's just go ahead and try it. It's 200 okay. So it says, yeah, whatever it was, I did it. And because we created something, we should have here we go. Because we created it, we got a response. If you remember, the return value of my custom function was the order number. So we get back value 11, which is the ID of the new order that was created. We should, in theory, I think, also get back. No, we don't get a location header in this case. Again, because we're not a real endpoint on a controller, we're being routed to by Jeff's custom code. So we're not getting that location header coming back. But again, if that's important to you, then just be a method in a controller, not a custom, not just an arbitrary method. But we should now be able to go and drill into that. Read order and items. So here's a query for OData orders 11 expand equals rel order items. So there's a query for the order we just created. And there's our full order. You can see order number 11 has been allocated. It's now got a GRFA in case we start updating it. We can see there's our 2 order items. And if we wanted to, we can start drilling into the vendors and all of the other stuff below there at this point. Okay, so there's an example of using arbitrary code in a custom class through the stored procedure or Sprach mechanism. Let's go back here and save changes, just in case we need to do a diff. Now we're really on the home stretch. Okay, so we've done all of this, we've reviewed that, we've looked at that, we've done that. Adding support for authentication, here's the interesting part. So I'm not going to go into a huge amount of detail about authentication. It was described by Jeff and by me a little bit more on Wednesday. So basically, just to re-emphasize that we're not doing stuff ourselves, we're just leveraging the Microsoft Core Identity Framework. So the provider at the back end could be any one of a number of things. I'm using a hard-coded, in this project, instance of Identity Server Community Edition right now, but more often than that, you would use Active Directory with Federation Services, Azure Active Directory, Facebook Authentication, login with Google, whatever it is you want to do. Any of those standard mechanisms, anything that provides an OAuth 2 provider or some other kind of provider that ASP.NET Identity supports. You know, it might be ASP.NET Identity also has support for just custom authentication schemes in a SQL Server database schema or whatever it is. It doesn't have to be Active Directory or something like that. It might be just a user password file. There's all kinds of standard providers that are supported by identity. So the features that we have are the ability to blanket require authentication in order to be able to access the service as a whole. We have the ability to protect certain types of operations based on roles. So, you know, saying that you can read anything, but you have to be a manager if you want to create something, or you have to have a may create orders in order to be able to do that. And we can restrict the visibility of fields based on user roles as well. As I mentioned on Wednesday, we probably have more work to do in this area, and very much looking for feedback on how much further do we need to go and what different mechanisms might we need to support to make this thing work the way you guys want it to. So the whole point is that the identity is managed by some trusted provider, in this case an OAuth server, and we're going to do two things. We're going to tell our service when it starts up that we're using authentication and where the provider is and who it's okay to trust this guy kind of thing. So we educate our server about the existence of the authentication server and tell it it's okay to trust it. And then from that point on, we have to first go to the authentication server, obtain a token, an access token, and we have to present that token to our service every time we call the service. And I'm going to walk you through all of those steps. Okay. So the identity server, again, as I mentioned, this is a fairly popular, from what I can see, I see it mentioned all over the internet, but what we're using is a free version, an open source version of something called Identity Server 4, and I'm also using a third-party extension to that called Admin UI. So Identity Server 4 is just kind of a back-end service that you just have to code against. Admin UI puts a very simple admin user interface on top of it so that you can create users and assign passwords and create roles and assign them to users and things like that. Identity Server does support a number of data stores. Generally, you would configure it with something like a SQL Server backend, but in the Community Edition, it only supports SQLite. So I've got a SQLite database in the project that's been provided. It's pre-configured. The other restrictions for the Community Edition is it only runs HTTP, it only runs on port 5000, and you can only have, I think, 10 roles and 10 users and 2 client IDs or something like that. So it's a severely cut down, limited implementation, but it's a real OAuth server. So we're doing this stuff for real, even though we've got a really limited environment, and even though we're running on HTTP, which is not what you want to be doing for your authentication server. I guess that's the way they guarantee nobody's going to use this in production. So the way we can start Identity Server is, it is in our project, all the source code's there, where it's a bunch of NuGet references, the admin UI source code's there. So we run it up, it's configured to run in IIS Express. So if you've got IIS Express on your system, which you should have if you've got the web role installed, which you should have because we're doing web stuff, so it will run up. It is possible to reconfigure the project so it just runs up in a console application or something like that as well. It's just another .NET Core application. So we're going to start it in IIS Express, and then we're going to talk to it. The database that I've provided is pre-configured. It has 2 users in there, Joda and Manny. The passwords are PAPS0RD in both cases. There are 2 roles defined. Joda is defined as an employee, Manny is defined as an employee and a manager. So we can show the differences between the 2. We've got 1 application defined, which represents our RESTful service that we're protecting, and I've just given that the arbitrary name API1, okay? And then we've got 2 clients defined, which allow us to access this information in 2 separate ways. The one we are using is the RO client, the resource owner flow. Jeff mentioned that in OAuth, there are, I think, 5 or 6 different flows Depending on whether you're an actual person or whether you're a software service or another web service, there's all these different flows for how you get a token. The one we're using is called the resource owner flow, and in that world you provide a username and a password and you exchange that username password for an access token. Okay, so we're pretending to be an actual person with a username and password. How authentication works, so the consumer, us in Postman in this case, or your application, your iOS app or whatever it is, first has to go off and contact the authentication server. So you're all familiar with it. You download an app onto your mobile phone, and the very first time you run it, it comes up with a login screen, right? And you've got to create an account or authenticate. Sometimes there's a login with Facebook link, right, or a login with Google. What you're doing is redirecting to Facebook's OAuth 2 login. Okay, and then you fill in the username and password and they generate a token and they send the token back to your application and it has claims in it and the app says, oh, I know who you are now because Facebook told me your name and your email address and your phone number and all that kind of stuff. We're doing the same thing here. Because we're using the resource owner flow, we're doing it without UI. Okay, it's a background call. Rather than redirecting to Facebook and seeing UI and having to log into Facebook, we're doing the exact same thing but headless essentially. Okay, so we contact the OAuth server, we present the username and password just as name equals value, values in the body. That's okay because in our example it's not, but you're going to be talking to the OAuth server through HTTPS, so all of that will be encrypted. Okay, and we're going to be identifying three things. We're going to be saying, I want to authenticate against API 1 for our web service, and here's my username and password. And it will give us back an access token, and that access token, one of the things it will contain is the roles that we have, or the claims they're called, but claims, roles, whatever. And you'll see all of this happening. So the server, our server, is going to be, once we turn on authorization, is going to be configured to trust the OAuth server, so it will know about the OAuth server. And we can also require specific claims or roles for some endpoints if we want to do that. So it may restrict access to things based on the roles we have at that point. In fact, it will, because it won't allow us to delete anything. Okay? And it may restrict some data coming back. And I've got in the repository, I've specified that there's a field in the customer record called tax ID. And I've put some code in the repository to say you have to be a manager to see the tax ID. Okay, so that's going to be our little demonstration. So the consumer then presents the JWT token to the server every time it interacts, and it does so via an authorization header. So it's a HTTP header in the request called authorization, and you include the JWT token as a bearer token, and you're going to see all of these steps happening. You've seen this, or a representation of this before. This is an example of the JWT. This is the decoded example. As you saw on Jeff's slide the other day, it's actually just a bunch of base64 encoded crap, right? It's not human readable unless you decode it, although I'll show you how to decode it online. And it contains role, employee, manager, scope, API 1. So API 1 is saying that this is information for our API, so we know we are API 1, and this particular person has these roles. Remember, that's what the JWT, again, it's very unclear, I apologize for the projector. The point is there are three sections to this. The red part at the top is the header. That's basically this part. The header simply tells us it's a Java web token, it has a unique ID, and it tells us the algorithm that was used to encrypt it. Okay? The body is what's represented in the light blue here. Okay, these are separated by periods, and the body, when decrypted, contains this information, okay? And the third part of the JWT, this is both of these encrypted. So this is the header and the body encrypted using the encryption mechanism named in the header. So what you do is anybody can decrypt these things, but what you do is you decrypt it and then you re-encrypt it with the specified algorithm and make sure the result you get is the bottom section. So if you re-encrypt it and get the same answer as the third section, you know that nobody's tampered with it. Okay? So anybody can peek into these things, but nobody in their right mind is going to authorize anything based on it unless our encryption of the top 2 sections matches the encryption provided in the 3rd section. Okay? So it's very lightweight, but very usable. Okay, so to do this stuff, we're going to do 2 things at once. We're going to turn on authentication and turn on field security at the same time. So let's do that. Let's go to our batch file and enable almost well, we're going to have one more thing after this, so we'll turn on authentication. So authentication basically says nobody gets to talk to this service unless you present me with a valid JWT. Okay, so you can't read, you can't write, we will not talk to you unless you've got a valid token. Oh, the other thing I should point out, by the way, and I haven't got any code for this in here, but the JWT also, EXP, has an expiration time. So the expiration time, I can't remember what this value is now. I think in our identity server, I believe tokens are good for an hour. But it's configurable. When you issue the token, you can specify, I'm going to issue a token for a week, an hour, a day, a year, or whatever. By default, in our environment, they're 3,600 seconds. So that token is good for the next hour. So in client applications, if you're writing a client to a service, you have to get the token back, look at the expiration, and know that it's only good for an hour. And you can use that one for up to that time. But after that, you've got to go back to the identity server. There's a whole refresh mechanism that allows you to update the token or get a new one or whatever. But they are time limited. Okay, so we'll go and turn those 2 options on. We will save our file. We will regenerate our code. And what did that change? Well, what that changed was some additional code in the startup class, some changes in the controller class, possibly some changes in some of the model classes if some of the fields are protected, and we'll see that in a moment, and API documentation files have been updated and so on. We have not yet, unfortunately, the Swagger environment with the API documentation. It is possible to configure it to know about the authentication server, and it will prompt you for usernames and passwords and get the token and pass them along and all that kind of stuff. We haven't yet got that figured out. So once we turn authentication on, we cannot use the API documentation to test the service anymore, unfortunately, but we will figure out how to do that as soon as we can. You can continue to use Postman. So let's look at what changed. In the startup file, here is where we are telling, or we're configuring our web API about our OAuth server, right? So we've got this Lambda that is identity server options, and we're telling it the authority is at this address. Require HTTPS, normally you would set that to true, but because we're using the community edition, we can't. We have to allow HTTP, and we're telling it that our API name within that environment is API1. This is us telling our web API environment that we trust this identity server, and this is where we expect tokens to come from. And this is the scope that those tokens are relevant to. And these are just the miscellaneous code that's required to set authentication options. Basically, this is just turning authentication on using JWT bearer tokens. What's this doing? Default policy, new authorization policy. Again, this is just enabling the use of JWT, require authenticated user.build. And here we're adding an authentication service and an identity server service with all of these options into our environment, and adding authorization based on those settings. Okay? And then lower down, we've also got app.useAuthentication, which turns the whole thing on. So this is configuring services that do it all, and this is actually enabling authentication in the environment. I think this is in configure services, this is in the configure method. In our controllers, the changes are we apply an authorized token at the controller level. So that basically says, I require a valid JWT in order for you to access anything in this controller. Okay? And at the individual route levels, so if there are protected fields within a particular model, and this is all conditionalized in the code generator, then this attribute, Harmony Field Security, enables the protected fields within the return data set. So this one we're getting because we turned on enable authorization, and this one we're getting because we turned on enable field security. Okay? And in the model classes, you may or may not have individual properties. In this case, let me show you the mechanism by which we did this. If we go to Tools, Synergy Repository, and we drill into Customers, and we look at Fields, and we look at Tax ID, again, hidden code in the long description. Long description is just a big old string that's a handy place to put secret little codes that CodeGen can do something with. So as well as sample data equals, we've got Harmony roles equals manager. So that basically says you have to be a manager to see this field. Okay. Now, yes, I'm aware this may not be extensive enough. We may need to break this out so that we've got a way of saying you may see this field, but you may not update this field and things like that. But this is the initial implementation that we've got. So that's where that's coming from, and the CodeGen templates take that and build that. If we look into our customers model, we should see that attribute somewhere on our tax ID there. No, it's not there. Huh? Oh, I did. You're right. Thank you. Thank you for pointing that out. There we go. Save that. Generate code. Back to the model. There we go. So now we've got authorized field manager. That basically says you have to be a manager to see this field, and clearly we need to be a little bit more capable in that area, but we'll get there. Again, looking for feedback. What do you guys need? Not necessarily right now, but give it some thought and get involved, because we know we've got more work to do in that area. Okay, so that's what changed. Other things you can do, we do have the ability to just blanket restrict operation types by roles. It's not implemented right now. Well, it is implemented, but it's all commented out. So the other thing you can do in our initial implementation is down here in the user-defined tokens. If you wanted to have a read-only service but make everything else based on a role, for example, then you could comment out roles post, put, patch, and delete. And now when we regenerate code, well, let's see, I'll show you what that does. If we regenerate code now, what we'll see in our controllers is that when we go, let's go to the bottom, you'll see that our delete operation authorized roles equals manager. So you have to have that role in order to access that endpoint to delete. Yes, it's a blanket one across delete across all endpoints right now, which again, I'm assuming is not good enough, but it's a starting point and we can manipulate it to do other things and maybe make it table specific, or I'm sure we have to make that table specific at least. Probably ultimately based on, again, the fields have a long description, but so do structures. So we'll probably wind up embedding some code into each structure's long description to say what roles are required for create, update, delete, that kind of thing, and take it from there. That, again, looking for feedback. Let's turn those off for the time being. That's just going to overcomplicate things for us for now. So we'll turn that off. We'll regenerate the code without those. And I think we can probably build and run at this point. Yeah, Swagger API docs doesn't support authorization yet, as I've already mentioned. Okay, let's build this thing. And let's run it up, and let's play with authentication. So we're going to have to get our identity server running, first of all. So we'll go to its projects, and I'm just going to say right-click, debug, start new instance. And that will start it up in IIS Express. It's also configured to pop up a browser to go to its home page. So IIS Express is now running down here in the taskbar. There's identity server. You can see it running on port 5000. Again, it takes a little while to start up. There we go. So this is the identity server homepage. It's really simplistic in the free version. It does have the admin UI to let you drill in and do very, very basic user management and roles management. So here's our two users, Joda and Manny. And I think we can see that Joda has the employee role but not the manager role, and so on. So it's a very, very simple UI. Generally speaking, you're going to be doing this in Active Directory and just using ADFS to get to an OAuth 2 endpoint, probably. But the end result is basically the same. So we've got a little identity server running. I've closed out the browser, but it's still down here running in IIS Express. Okay? So it should be good for us to talk to. So what we should find now is if we go off to, well, we need to start our service, of course. So let's do our Control F5 and bring up our service. You'll notice it's reporting some additional information here because it's now got authorization turned on. It's talking about data protection keys and blah, blah, blah. So that little change here is telling me that it knows about the identity server. So in theory, if we go off to Postman, we should ideally, hopefully, not be able to do anything other than talk to the identity server. So I'm going to close all of these tabs, and let's see what happens. Let's try read a customer. So read customer, let's try and read customer 8. First call always takes a little while. 401 unauthorized. Okay, so I'm trying to access the service and it's saying, you didn't send me a token. I don't know who you are. I'm not trusting you. You don't get to talk to me. And all of our endpoints will do the same thing. Basically, nothing in this service will talk to me at this point. If I want to, I have to provide a JSON web token in a header. So we have to go, first of all, get ourselves a JSON web token. Now, clearly, if I'm writing a mobile app or something, it's just I'm going to call the identity server, get the token, pass it on, and so on. Here, it's going to be a manual process. So down here already, I've got two options, get access token for Joda and get access token for Manny. These are just a post to the identity server's connect/token URL. That's the token endpoint for this particular server. All OAuth servers, by the way, I forget what the URL is now, but they all have a well-known URL that if you go to, it serves up a list of all the endpoints of all the different token endpoints. So it tells you if you want a token, you go here. If you want something, go here, and it lists them all out. This one does it as well. I just can't remember what the URL is. Oh, actually, maybe it'll tell us. Actually, yeah, it might do. Does it tell us what the URL is? Yeah, here we go. So this is the URL is base address .well-known/openid-configuration, and all OAuth servers will have this URL available, and it's listing all the endpoints. So we're going to the token endpoint to obtain a token. So it's telling us it's localhost 5000 connect/token. Okay, so that's how you discover where to go to. So generally, your client app would know the base address of the authentication server and would make a GET request to retrieve this metadata, and would then extract the token endpoint and would then go and talk to the token endpoint to get a token. Okay, so that's normally the flow. I'm kind of shortcutting a couple of those steps. So what we're going to do here is we are going to, we'll close that down again. So we're going to that URL. In our body, we are providing grant type equals password, username equals Joda, password equals password, client is ro.client. That says we're using the resource owner flow. We're exchanging a username and password for a token, and client secret is, that is the secret value associated with my API. So API 1 has a secret value associated with it that I have to do. That basically is associating me with API 1 with this username and password, and I'm asking for an access token based on that. So if we do a send, hopefully there's our token. So we got a 200 OK, and there's our access token. Okay, and it tells us expires 3600. So we got an hour, basically. Okay, this one's good for an hour. If we take our access token, carefully, the data between the quotes. And if you look at this carefully, you'll see it has those three parts. There's a header and a period and a body and a period and a footer and a period. Okay? No period at the end. I'm going to copy that value just to show you that it is a valid JSON web token. There's a natty little site out here called jwt.io, which is the JSON Web Tokens project homepage, I believe. And one of the things you can do here is if you paste in your JSON Web Token, it will decode it for you. If you tell it about your public keys and things, it will also validate against the signature, but it hasn't done that. So the point is, anybody can decode it and look at it, but the second step is you would take the decoded information, encode it using the algorithm, and make sure it matches the third part. So that's the step we're not doing, okay? So we're just assuming it's okay. Well, our web API will be doing that for us, but we're not doing that here. But you can see that here that it says this is a role employee scope API 1, okay? So if we present that token to our service, remember that the last time we tried to do this, it told us 401 unauthorized, okay? In Postman, it has a natty little useful thing that allows us to go to authorization, and I'm going to tell Postman that I want to use a bearer token, which is how you present these things. And it says, I've pre-configured the Postman environment. Postman has variables that you can use. And you'll see here, it's saying the token is brace brace AD access token brace brace. That's a placeholder for a Postman variable. And I've preset up all of the operations to have this. So the way we use this is we go and edit our collection. And in here, we can say edit. And in here, we have variables. And you'll see I've got it's named wrong. Okay, let's name it AD access token. And I'm going to paste our access token into that variable. So now I've got the access token in my project. I can just specify it to all my operations. Okay, I've just put it in a variable in Postman. So we'll update that. And then what you do is you say preview request. And what that does is it inserts for us, you'll see it now says headers 2. So it inserted authorization bearer AD access token. It'll translate that value and insert the token. So it's passing the token to the service through a HTTP header called authorization. Now if we do a send, we get our data back. Because our identity server received the token, decoded the token, validated the token, and said, yep, you're a valid user for API 1, I'm going to allow you to access the service. Okay? So there's an example of using that. Now, let's show you the other kind of authorization here. So we're logged in. Remember, we obtained our access token for Joda. Joda is not a manager, so Joda should not be able to see tax ID in the customer file. So if we go to customer tests, read customer, well, we just did, didn't we? It's there. I don't see tax ID there. Okay, so that's been hidden based on roles that Joda does or doesn't have. Okay, so to prove that that part of this is working, if we go back to our identity server, but this time I'm sending a request for Manny, password is password, same thing as before. So we'll go off and so here's an access token for Manny, and sure enough, if we grab the token, let's just prove the point. Let's go back off to jwt.io, and now if we paste this one in, we should find that Manny has roles employee and manager. Okay, so that should, in theory, enable the viewing of the tax ID field. So let's go off and take that value, and let's update our project variable. So we'll edit it, go to variables, reset it, and insert Manny's token. Okay, and then if we go back to our read customer operation, where are we? Save, why is it asking me to save? Okay, let's just do this a different way. Read customer, oh, there we go, send. Now we see the tax ID. Okay, so that's the basics of how authorization and authentication work in this role. So authorization saying you can either access it or not, and authentication, and authorization restricting what you can do based on roles. Okay, let's shut down our server. Let's close down our identity server. Oh no, we better leave it running because we need it now. Do we? Yeah, no, we need it running. Okay. All right, what is next? We're on the final home run. This is perfect. We've got 15 minutes and one more thing to do. I think we are in great shape. Let me first of all save away these changes. So auth, commit all. All right, our final section is going to be unit testing. This is something where we haven't done a great amount of work in this area. I've lost my place, bear with me a second. Here we go. All right, unit test generation. So again, we're going to turn on an option that says enable unit test generation. Let's do it first and then we'll talk about what it does. So we'll enable unit test generation. By the way, the remaining things are just little options that you can choose in the environment. So enable case-sensitive URLs. On Linux, for example, it's normal to have case-sensitive URLs. We kind of suppressed it because we didn't particularly want that behavior. But if you want case-sensitive URLs, you can have them. Richard talked about CORS, cross-domain authentication. So if you want CORS support so you can talk to this thing from other places, then there's an option there to enable CORS support. And if you want to host in IIS, then there's a little service that gets injected and you just turn on enable IIS support, and there's a couple of changes in the startup code that enable you to host in IIS. So that's what those remaining 3 things are. Okay, so let's go, we've turned that on, let's generate our code. And that created a whole bunch of new stuff. Okay, so what we're going to do is, we haven't changed anything in our services project at this point. Our services are done. What we've done now is generated a whole bunch of stuff into the test project. Okay, so I'm going to just go through and add it all. Existing item, test, let's add all that code in. We've got data generators, add existing item. We've got model classes for use on the client side, existing item, models, done. We've got a whole bunch of unit tests, add existing item, unit tests, done. Okay, let's just set that. No, there's no point setting it as our startup project. Let's just make sure it all builds, and then we'll take a fairly quick spin through what it does. Okay, so it all built. What these things do is, these data generator classes are a similar environment to what I showed you before, the creation of the ISAM files. The data generators, just for each file, open the file and read up and return a collection of vendors, customers, orders. So it loads up the text files and it opens the text files, reads all the data and returns a collection of data. So that's all those data generators do. The client-side models are very much like the server-side models. They are used to, when we're going to call a method, we're going to get a customer back, and we can use these to deserialize the JSON data into, because we're the client now. We're going to make the HTTP call and get JSON, and then turn it into a customer object. So these classes are to allow us to deserialize that JSON data into actual data. So there's one for each type of entity. We've hard-coded, there's a test constants.values class that has properties, sorry, not test constant values, test constants properties. So for all of the unit tests we generate, we've generated these values that we can use to inject customer numbers and order numbers and stuff into our unit tests, okay? And I've hard-coded, so it's a partial class, that declares the properties, and then this sets the values we're going to use for all of our unit tests. And I've hard-coded and given you a pre-existing copy with usable data in there. So you'll notice we've got item 1, item 6, or vendor 38. These are just sensible values that will result in stuff working in our unit tests. So I'm going to take those and paste them over the actual values that were just code generated. This values file is set up to be code generated one time. The idea is you code generate it, you edit it, you fill in the values, and it won't get overwritten. Okay? So that's essentially what I've just done there by pasting that code in. There's a whole test environment and unit test environment. I'm not going to go into a huge amount of detail because I do want to finish at 3 o'clock. But it's doing the similar things to the self-hosting. It's creating logicals, deleting files, recreating files, deleting it when it's done. And the unit test environment basically has, if you've ever done any unit testing in Visual Studio, you'll be familiar with test class says this is unit tests. Assembly initialize says run this code before all the unit tests. We're going through the same process. We're configuring the test environment, which creates all the data files. We're setting up the self-hosting. We're creating in code. We're creating an instance of the HTTP server, very much like we did in the self-hosting program, but this is all just done in memory inside the unit tests. So we create a running instance of the server that's hosting all of our services, and then our unit test classes simply run operations against it. So here's unit tests for customers. Test class makes the environment go look in this class for tests. Test method says this is a unit test. They're categorized. That's not used right now because the Test Explorer in Visual Studio isn't working with this stuff right now. But you can see we're just creating we're taking unit test environment server create client, gives us an HTTP client, client.set bearer token. So it goes off and talks to the identity server and gets the token and passes it along. So this is typical code that interacts with an HTTP service in a client. Okay, and we're just going off and retrieving all customers. We've got some more work to do in here to validate that we got the right number of customers back and all of that kind of stuff. But it's basically calling into operations. Here we're doing calling into customers and doing an expand rel orders. I'm just making sure we get a success status code back from the operation. So we could be doing a better job of making sure we get the right data back and the right number of orders and all of that kind of stuff. But for free, it's a good validation that the environment is running. So there's you can see there's quite a lot of unit tests. I think I'm not sure how many there are, to be honest, but there's quite a lot for each of our entity types. Like I say, one day it will be nice if this all worked in the Visual Studio Test Explorer like it does in Full Fat Framework, but it doesn't right now. So the way we have to execute these things right now is down at the command line. So I'm going to go Tools. I'm going to do open a command prompt, and it's put me in the right directory. So the way we can run the test is by saying .NET test, and it's going to run up the service and execute all of those unit tests and report what worked and what failed. So starting test execution. Test run successful. Total test 59, passed 59, failed 0, skipped 0, test successful, and it took 9 seconds. It doesn't usually take that long. Oh, I don't normally run it with identity turned on though, so I guess that's probably slowing things down a little bit. Oh, 5 seconds that time. So it's a fairly basic environment, but if things fail, there's big red messages everywhere. So there we go. All right, we have 5 minutes to spare. This is basically just talking about what happened and what the unit test environment looks like, and we've been through this stuff. And we've examined it, and we've run it, and we've got us run successful, and we're not going to do that because we're pretty much done, and that's all I got for you. Thank you very much for joining us. I would like to ask the remaining people here to give this guy a round of applause because he has done some awesome work on this, and it is truly amazing, and we're really looking forward to getting you guys into using it, and please give us your feedback. If you find specific problems, GitHub repository issues, feel free to log an issue, feel free to comment on existing issues, feel free to suggest improvements. I know that there's some great documentation out there on some really technical stuff about how the nitty-gritty stuff works. What we're a little bit light on right now is just procedural documentation of how do you do this stuff, and I will be focusing on that as soon as I can to try and get that information improved. Let us know what you think. Okay, thanks guys.